Good evening. Today's title is Electrochemical Cells. Let us answer the statement question written here. Statement 1. In both galvanic and electrolytic cells, anions migrate to the anode and cations migrate to the cathode within the electrolyte. Statement 2. In both galvanic and electrolytic cells, the direction of electron flow along the external circuit is from the anode to the cathode. From among the usual options for statement questions, the correct option for this particular question is both statements are correct. Let us seek the explanation for such a conclusion. We know that electrochemical cells is the general term for both electric or galvanic cells and the electrolytic cells. In the galvanic cell, electricity is produced out of the free energy change accompanying a spontaneous chemical reaction. Whereas in electrolytic cell, electricity from an external source causes chemical reactions to occur around the electrodes. In both these cells, anode is defined as the oxidation electrode and cathode the reduction electrode. As a typical galvanic cell, consider Daniell cell. It involves zinc electrode coupled to a copper electrode via a salt bridge. Symbolically, it can be represented as zinc metal solid in contact with zinc sulfate solution aqueous. Double vertical line represents connection through a salt bridge. Copper sulfate aqueous in contact with copper metal solid. The spontaneous reaction at the zinc electrode is oxidation. So zinc electrode is the anode. So this will give 2 electrons plus zinc 2 plus. Already we have zinc 2 plus SO4 2 minus neutral zinc sulfate solution, to which extra zinc 2 plus ions are introduced. So this solution becomes positively charged. Electrons can reside only on the metal, and the electron-rich zinc plate now becomes negatively charged. On the copper electrode side, copper 2 plus ions migrate to copper metal. Copper metal will provide 2 electrons, and together they form reduction to form copper metal. Reaction occurring here is reduction. So this is the cathode. And the copper metal, due to loss of electrons to copper ions, becomes positively charged, whereas the copper sulfate solution, due to loss of its cupric ions, sulfate becomes in excess and the solution becomes negatively charged. Suppose there is no salt bridge. The electron-rich zinc metal and electron-short copper metal, on being connected by an external wire, one can observe a flicker of electron flow through the external circuit from zinc to copper, but it immediately dies out because The positive zinc ions will hold on to the negatively charged zinc metal, holding the electrons there, whereas the electron shortage of copper plate is almost neutralized by the excess sulfate ions surrounding it. In order to ensure smooth electron flow, the two electrolyte solutions have to be connected by a salt bridge which ensures ionic flow between the electrolytes. And the ionic flow will be such that negative ions will be migrating to the positively charged electrolyte solution. So anions actually migrate in the direction of the anode, and positive ions will be migrating to the negatively charged electrolyte solution of copper electrode. So cations migrate to the cathode. Thus in the galvanic cell, anions migrate to anode, which of course metal is negatively charged, but solution is positively charged. And cations migrate to the cathode, where the metal is positively charged, but solution is negatively charged. Ionic movement ensures the neutrality of solutions, and the electron flow along the external circuit continues. And the direction is from the anode to cathode. Coming to electrolytic cell, consider electrolysis of molten sodium chloride, where we have Na plus and Cl minus in a molten state, into which electrodes, neutral electrodes are dipped, which are connected to a source of external electricity. This is negatively charged, this is positively charged. This is the electrolyte solution, electrolyte liquid. The positive ions migrate towards the negatively charged metallic electrode, and the negative ions, chloride ions, migrate to the positively charged metallic plate. And at the negative plate, the electron-rich negative plate gives electrons to Na plus, and it gets reduced to sodium metal. Being in a hot situation, it will be formed as liquid sodium. Being a reduction, this electrode is now the cathode. So during electrolysis, the negative electrode is the cathode, and on the positive electrode side, Cl minus will be giving the electrons to the positive electrode, getting itself oxidized to chlorine gas. Being an oxidation electrode, we can call this as anode. And the electrons will be flowing to the positive end of the external cell, and from the negative end, electrons will be fed into the cathodic plate. So the direction of electron flow is from the anode to the cathode along the external circuit, and direction of ionic movement is cations to the cathode and anions to the anode. So in both cells, what the two statements tell are correct. That's all.